Okay. So what we're going to look at here is we're going to kind of deconstruct our box method stuff. So this is in your book on page 90. And we want to know, how does this shape represent x plus 4 squared? What do you think? Kind of weird looking. I'm going to draw on this a little bit while you think. I'm going to put lines on it like that. What's inside this box right here? Just an x squared. What's inside this box here? 4 x's. 4x. Yes, dear. Uh-huh. Yeah. So that bottom left hand or bottom right hand side is 16 ones. I'm gonna try to do this with the chunky marker. So that's 16 ones. This is another 4x. So how big are the sides? Like if I looked over here and we maybe tried to pull out the length of the side. If I know that this times this gives me x squared, how far is each of those sides? X. How long is this side? 4. And how long is this side? 4. So this is, when you use these tiles, what you're doing is you're building the box method. So each side is x plus 4. So we have x plus 4 times x plus 4. Also known as x plus 4 squared. So whenever our sides match exactly, we're going to wind up with our perfect square. So what we're going to do is, go to the next page, there we go. I want you to get out from your set of algebra tiles the tiles to build x squared plus 8x plus 10. So an x squared, which is the big square, 8 x's, which are the little green rectangles, and 10 ones, the little squares. So grab those from your bag and then pass your bag to someone who doesn't have a bag, because I only have so many bags and those bags are super full. So you should have a set that looks kind of like that. Lots of these big squares. And what I want you to do is I want you to try and arrange this set into a perfect square. I want you to try and make a square like we did with the X, with the one up above. I'm not going to bag it just once. Hello, sir. Yep. Thank you, sir. Yeah. I think that's 11. See if you can get this into a perfect square, and then see if you can answer the questions on 91 with it. Try and get it to match. What are we doing? What problems are we running into? You all have, I was gonna say y'all have way more than you need. There we go. It's all good. Try and arrange them in a square. One big square. What do you think? Can we get it into a perfect square with just these tiles? These ones up on the board. With just these, can I get a perfect square? No. If I get my sides to match so it gets me close, I don't have enough of the little ones to fill in this little nook down here. I wish I had more. How many more tiles do we wish we had so that we could make a perfect square? 6. I wish I had 6 more tiles. If I had 1, 2, 3, 4, 5, 6 more tiles, I could make my perfect square. I could fill it in if I had 6 more. So what we're going to be doing, because we want to start being able to switch from standard form into vertex form, this is our standard form. In order to get vertex form, we need to make it be a perfect square. I need a dry erase marker so I can write on my actual board. The actual dry erase board. So I really want it to actually be able to be in that perfect square. I need to use the x squared and I need to use all the x's. The ones we can kind of play around with like Play-Doh. Because I can say, all right, I'm going to add 6 in here. I want a plus 6 over here. But I cannot take my equation, which is perfectly level, and just add 6 to one side. That don't work. So if this is x squared plus 8x plus 10, and I would like to add 6 more to it, what do I need to do to keep my equation balanced? If my goal, I would love to add 6. What do I do if I want to add 6 to one side? How can I keep it balanced if I want to do that? Right now I'm adding 6. What can I do?
You can find a GCF.
Not GCFing. I'm just going to say, what if it was, I was like, Bob, Fred, and Purple, and I wanted to add 6. What can I do to keep it balanced so it's not tippy? What can I do to both to an equation on both sides? Both sides. When in doubt, do the same thing to both sides, because I can add 6 over here if I want to. I don't change things. So if I add 6 to both sides, oh, it's so pretty. There's a perfect square. And we have x plus 4 here and x plus 4 here. So I can rewrite this thing, if I include this 6, as x plus 4 squared equals y plus 6. We generally do not like to have y plus 6. So what can I do to get y by itself? Subtract it. So we're going to wind up with the vertex form of this equation is x plus y, or not y, that's a 4, x plus 4 squared minus 6. So you can get into vertex form without ever touching factored form using these kind of box method square things. And that's what we're going to practice doing today. So we're going to look at page 92. And you can use the tiles for this. I'm 100% okay with that. What this is doing, and honestly, the model that they've shown here is objectively terrible. Gross. Super gross. Because they kind of put it into a table in a software that kind of programmed it kind of weird. That band on it is just nasty. Because what this is, they're trying to do this thing and put our factor form on the outside. So what happens, and what we're going to do here is we're going to identify some perfect square pieces, like it has down here. What would we do to build a perfect square for a minus 8x? How would that be different than this plus 8x? If you've used algebra tiles before, what that means is you're going to use the right side. But I generally don't care. The tool you can use it how you wish. Alright, so if I have x squared and minus 8x, what piece am I missing in order to make a perfect square? How could I start to build a perfect square with that? We need OC. That's what I'm trying to figure out. I want to figure out what that number is going to be for that C. So when we try and build this, erase this. Try and build this as a perfect square. minus 8 x's. So 8 negative x's. How could I split that up to make that into a perfect square? How could I split that minus 8 properly? If I want to build this in a perfect square, where are these going to go? What do you think?
4 on the bottom, 4 on the side.
4 on the bottom, 4 on the side. So it's very much like that plus 8, but this time it's minus 4 down here, minus 4 down here. That way. Helps when I line things up right. So what that tells me is that on the outside we're going to have x and minus 4 and x and minus 4. What's going to go here? Not 0. That's how many we have right now. If I wanted this to be a perfect square, but I can write this that way, what should be here? 16, and a positive 16 at that. So I would love to add 16. That's my goal. So if we have x squared plus 8x equals y, I would love to be able to add 16 to both sides. That would let me put this as a perfect square. This was minus. There we go. So we're going to have x minus 4 squared equals y plus 16, right? Again, we don't like the y, so we're going to bring it over. X minus 4 squared minus 16 equals y. So when we're doing this, like in the box that they haven't given you, I just put one on the screen because I'm hopping. We're splitting this into pieces with our x squared. This piece is always going to split in half. So it's minus 4x and minus 4x. That tells us what our factors are, x and minus 4 and x and minus 4. So that we can figure out that we are going to love to add in 16. You don't have to do the hard thing. That's just me being weird. To help us remember, I want to add that in. I'm choosing to add that in. That's not something the equation gives us. So we are going to get our x squared minus 8x equals y is going to become x squared minus 8x plus 16. And we can add that 16 to both sides because I'd like to do that. Because then I can write this as a perfect square here. X minus 4 squared, y plus 16. Which can get our vertex form of x minus 4 squared minus 16 is our vertex form. So we can get to the whole vertex form thingy just by figuring out what that random piece is that I would really love to add. Figure out what pieces we're missing. So we're going to try that with a few of these because some of them are a little weird. So these are ones that we're going to figure out what pieces we're missing. I would love to be able to put these in vertex form. So this is question B from that same page. I want to know what the piece that I would love to add is. What is the missing piece? So you can think about it with the tiles. You can always grab tiles if you want to use tiles when we do our quiz next week. I'm 100% happy to hand you tiles. If you like the tiles, great. How can we divide up a minus 10x to fit into this box perfectly? Not 20, I see where you're headed, yes. So x squared, because how did we get to that 25? What's gonna go here?
5.
Yeah, minus 5. This 10, we're gonna split it in half. Minus 5x and minus 5x. So this box that I would love to fill in here is going to be a positive 25. So if we wanted to put this into a vertex form, it's going to be x squared minus 10x plus 25. And you can do the whole equals y thing, or we can realize we're subtracting it as well. Plus 25, and we're going to get x minus 5 squared minus 25 equals y. Okay? So we're filling in this piece. On the homework for completing the square, the first section is fill in the blank. What would that number be? So you don't have to get all the way to vertex form. It's just fill in the blank. So in this case, I do find the box to be helpful with figuring this out, but that's just me. So if we're going to have our x squared, how are we going to split that 14x between these two boxes? This is option D. How are we going to split the 14x between these two boxes? 7x in each one. Which means what's my piece that we're adding in the bottom? 49. So 49 would be the number it takes to complete that square. E is probably the hardest one on this page. Again, our x squared goes in the top left, always does. How can I split 5x into these two boxes? Exactly the same. 2.5, but yes, correct direction. Yeah, exactly right. We are going to legitimately cut the dang thing in half. 5 halves x, or 2.5x. Genuinely, I do not care if it's decimal or fraction. I'm going to match it just because that was wrong. So what's going to go in the bottom box? What's the piece I need to add? Sounds about right. 6.25. 2.5 times 2.5. Decimals are okay. And these are going to be the times that we use this technique. For the most part, doing the factor and find the middle is way easier than doing this, because complete the square is the bane of every algebraic person's existence. Like 100%, this is the thing that everyone goes, oh God, I hate that so much. But if we want to go from standard form to vertex form and it doesn't factor, this is the way we do it. Okay? We're going to practice a couple more of these. It's actually, I'm not entirely sure that's the right page number, but it might be. It is the right page number. Yay, for me actually getting things updated correctly. Woohoo. We're going to do these two, and that's it. And then Monday, we're going to do a couple more of them, and that'll be it. Like, we're not adding more on Monday. The only thing that's going to be different on Monday is they're going to have A values that we have to deal with. So this is going to be the whole thing. You're given a whole equation, and we're asked to put it in vertex form. So what we're going to do, when we have a whole equation that we're putting in vertex form, we started with number 2 because honestly number 1 is gross, but we're going to do it next because it's important. We're going to complete the square on this guy, just like the pieces we just did, and ignore everything else for a hot minute. So just looking at our x squared plus 2x, how are we going to fill in our box for our x squared and our 2x here? X squared and the 2x splits how? 1 and 1. 1x and 1x. So what's the piece that I want to add in right here? That heart is terrible. What's the piece that I would love to add in right here to make this a perfect square? 1. So I would really like to write this purple blob as x squared plus 2x plus 1, so that I could write it as x plus 1 squared. But I can't just willy-nilly add a 1 inside my parentheses unless I also take it away from the outside. Or you can add it to the other side. It doesn't really, how you do it doesn't matter. And then we can put our 120 involved in this process. So our vertex form, when we fully simplify it, minus 121. I know I just kind of like whipped through that. Did I go too fast? Like all of a sudden I wound up at the answer and it felt really, really fast. Are we okay? Because that's our answer. That's g of x in vertex form. So take your little piece with your x squareds and your x, complete the square on the tiny piece, and then work your c value in to your vertex. So we're going to complete the square on the tiny piece, combine like terms, and we're done. Okay? Let's do one, and then we'll be done, and it's a Friday, and we can stop, because it's Friday. Same deal. I'm going to look at just these pieces, and we are going to complete the square on just those pieces. So when we go to put it, if you want to use the box, you can. 100% I support that tool. It's a great tool for this. When we have our x squared, how can I split my 3x into these two boxes exactly the same? $1.5 and 1.5x. Which means what is it that I would love to add in here? 2.25. Gross, but that's okay. So if I come over here to my equation, I would love to be able to rewrite this as x squared plus 3x plus 2.25 so that I can put this as x plus 1.5 squared. But again, we can't just add 2.25 into the middle without taking it away from the outside. 2.25 minus 18. Okay, so you can put it on both sides of the equal sign or add it to both sides. You wind up with the same place. It's a shortcut. My pen's being a jerk. So we're going to wind up with a k value here of negative 2.25 minus 18 minus 20.25. So our vertex here remember our vertex is h comma k. What's our h value on this one? So h value's here. What's our h value on this equation? Careful, watch your signs. Negative 1.5. It's always going to have the opposite if it's inside of parentheses. What's our k value? Negative 20.25. These are the kind of one where you're asked to find vertex form from this. Those are going to be the kind that we use complete the square on. The first one, we could factor that one. It's gross, but we could factor it and find the middle. Totally fine, 100% valid. Both methods work. And when it comes to things on like the review, most of the time when I'm asking you to put it in vertex form, I'm also asking you to factor it. So you can either complete the square or you can do like we did the other day where we took our factored form and found the middle. We did that with our catapults. We found what was exactly in the middle and that gave us part of our vertex. Valid. 100%. That works. This also works. Okay? There is a homework on completing the square, which for some reason is not on my screen. It's homework 4. It's the last homework of topic 6A. T6H4, complete the square. And I believe it is, yeah, it's page 96. So it gives you more practice on this completing the square stuff. All right? I encourage you to try it, encourage you to do it. That is all we've got for today. You have 10 minutes left. The around the room thing is coming down at the end of the day today. So if you need more time on it, now is a great time to do that. There is also a PDF copy that I'm 95% sure I put online for Monday's day, where you can continue to work on it if you're not getting to it, but it is coming down today. Okay? Partly because the choir competition is using it this weekend. Using my room. So we don't leave up things that are valuable. All right, you guys have 10 minutes. Work on stuff. Ask questions. The review guide for the quiz is available. It is in the hangy file thingy under the pencil. I believe it is the centermost option.